While you are writing down that definition, you're probably done by now, but I just want to read to you something that I will be sending home if you are currently failing by the end of class. So it says, Dear parents and guardians, I'm reaching out to inform you that your student is currently failing summer school for Algebra 1. As we approach the final stretch of this course, it's critical they begin making immediate progress to meet the requirements needed to pass. Tomorrow will be a key day in their progress. Students will take a quiz on recently covered material, begin working on their final exam review, and have the opportunity to retake quizzes in order to improve their scores. To minimize distractions and help students stay focused, I will be implementing the following policy moving forward. Students who do not currently have at least a 60% overall in the class and an 80% or higher on their final exam review will be required to turn in their phones to me during class. If a student or family has concerns about this, I'm willing to allow phones to stay in backpacks only if they are turned off and not taken out at any time. If a phone is seen out without permission, the student will be dismissed for the day. Our goal is to help every student succeed, but focus and effort are essential. Please encourage your student to take full advantage of the opportunities provided, especially as the final exam will play a major role in determining whether they pass the course. So again, I'm only sending that to people who are currently failing. Well, I mean, by the end of class, because maybe you get your grade up by the end of class, who knows? But I just want to make that really clear since I told my AM session, like, you have all these opportunities, like, you can do all your missing work, like, you can retake every quiz. But I still see kids that have Fs and know that they have Fs sitting on their phone, watching videos on YouTube, playing games on their computer. And I've already told you guys a bunch of times, like, no phones or headphones out, and yet still people are taking them out and doing whatever they want. I'm over it. This isn't like a five-star resort. This isn't a vacation. This isn't a reward. If you want to be one of those people that is in danger of not getting credit and don't want to be like away from your phone while you're in here, I'm going to send you to admin and you can explain to them why you're like, it's really very simple. I spent a lot of time teaching you, and I've seen other summer school teachers, not necessarily during this summer school session, but like in past summer schools, please open your eyes while I'm talking to you. In past summer schools, just sit you in front of a computer and it's your responsibility to learn it yourself. From like IXL, maybe videos. But no, like I've been here teaching you everything. Everything that's on your quiz is something that I've stood up here and talked about, that I'm currently right now recording myself talking about so that you can rewatch it later if for whatever reason we're having a bad day, couldn't pay attention, I don't know. But it's all recorded and linked in the slides this whole thing. And not to mention, there's practice quizzes that sometimes even pull the same questions from the actual quiz. Some of the homeworks pull the same questions from the actual quiz. Like, there's no reason that I do have so many Fs. During the school year, I had 5 Fs during the entire school year. And that's like really unheard of for like Algebra 1. That is the most failed course. But no, like my students are always really successful because of the way that I structure the class. Like it's really on you. I'm certainly not going to do your homework for you or take your quiz for you, but I have taught you all this stuff. I let you use your notes. Like there's no reason. This class isn't necessarily as bad as my AM session. I have like a lot of people failing in my AM session. So like I will give you guys that piece. But like still there's too many people doing whatever they want when like they're not asking. And if it were me, I'd be working my butt off so that way I wouldn't have to come on June 19th, which is the official last day. Because they said, like, if you are meeting all the attendance requirements, so if you've been here the whole time, not missed a day, you pass your final first try, and you have a 60% at least in the other part of the class, then you don't have to come that last day. But one, if you already missed a day, well, you have to come no matter what. Sorry, that's cool. But two, like you still have to pass the final, pass the class. and expect to be here Thursday. Every year, there's kids that like schedule vacations or they schedule work on that very last day, and then they get all mad at me when they don't pass their final first try. Like no one told you that it was a guarantee. So make sure that you're here unless I tell you on Wednesday that you don't have to. Like I personally tell you, hey, blah, 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 you don't have to come. Otherwise, plan to be here. There's always a lot of kids here. It's not that big of a deal if you don't pass it the first time. Lots of kids fail their finals. But for summer school, you have to pass it to pass the class. So that's where we're at. Tomorrow, you'll have a quiz on what we're learning today. And then you'll have time to work on your final exam review. And then you'll have time to do retakes. And that's really like, hopefully going to be the last stretch. Hopefully I don't need to have people here on Thursday retaking a bunch of quizzes to try and pass. But I can anticipate like that's what's probably gonna happen. I would just do all the work now, in my opinion. But hey, I can't make you do it. So keep that in mind. We only have a few lessons to do. We're gonna do them all today. We're not having a quiz today because we ended on a quiz Thursday. So tomorrow's quiz will be the last one. So by the end of, hopefully I have time to figure stuff today. By the end of today, your grade should be 100% up to date minus that one quiz and the review. The review I'll make available to you like today if you want to get a head start. Because even the people that aren't failing, I will ask you to turn in your phones so that until you get 80% or higher in your review, that's going to be like your little reward. You want to have free time, okay, you need to be passing, and you need to get 80% or higher on your review. I do that with my math lab kids. Some of them come to my math lab with their work already done because they want to sit on their phone and hang out. Okay, but they know that they have to meet the goals in order to do that. So that's what we're doing. Okay, so that's not fair. Okay, well, how about you watch that little snippet of the video? We gotta get moving into actual content. I'm actually use that about your grades for the past 5 minutes. That's what it's gonna be. All right, so moving on. Again, we only have a couple lessons to do, starting with this one. Hopefully you already wrote this down because I asked you 2 minutes ago. So if you have your Chromebooks open, you really don't need them at all for this lesson, but I'm going to close them. But for this one, we have a relation in which each element of the domain is paired with exactly one element of the ring. So that's what a function is. On your exam, you're going to have to identify which, if any, are functions and which are not. Yes? 14 minutes ago, I have to write this down. We need to get a pencil out until right now. Okay. So functions, you need to be able to identify them no matter how they're given to you. Whether it's like a bunch of coordinates, a graph, a table, a map, you need to be able to tell me if it's a function or not. So let's break down this definition. There's lots of words in there that you don't recognize. So relation, that's just like any set of ordered pairs. So we don't really need to break that down, but like any set of ordered pairs, whether it's like a graph, table, map, list, set of ordered pairs is what a relation is. Some of those relations we would consider functions, and that's if each part of the domain is paired with exactly one element of the range. What's domain referring to? Okay, so it describes all of the x's. So if I want to write that down, if you didn't already know that, I know my students know this probably better than they know anything else. Domain is all the x's, and then range is all the what? One. Set. And then later we'll be talking about reasonable domain and range as they like talk about real world situations. But all you really need to know right now for this page is domain is all the x's, range is all the y's. My students remember it with Dr. XY. GZ Cordway, Dr. XY, so like almost like highlights like everything, so probably popping. But XY, like in the alphabet, X before Y, and doctor is just a way to memorize that domain is all the X's, range is all the Y's. So functions have where each part of the domain is paired with exactly one part of the range. So each X has exactly one Y. So if you see that you have like a list of coordinates, for example, and you see that the X's do not repeat, that's automatically a function. I don't even need to look at the Y's to tell you that it's a function. As long as the X's don't repeat, it's a function. If they do repeat and they have different Y values, it's not a function. So that's like plugging in the same number into the same equation and getting two different answers. It just doesn't happen that way. So to test whether a relation is a function, check if the X values repeat. If they do and it's different Y values, it's not a function. If it's a graph, we can use the vertical line test, which basically is checking for the X values just in a slightly different way. So if a vertical line intersects a graph more than once, then it is not a function. Depends on the definitions. Okay, so in addition to determining whether or not these are functions or not, we're also going to identify the domain and range. So starting with number 1, take a look at it. These are ordered pairs. What order do the ordered pairs always come in? Like what's always first in an ordered pair? Okay. So looking at the X value of each ordered pair, do I see any that repeat in number 1? All right, no, I don't. So is this a function? Yes. The X values don't repeat, it's a function. Now we're going to identify the domain and range. So domain is all the what in a function? All of the X's. Now, if we're just going off of a list of coordinates, this is how you could write the domain. You would use a fancy brace, kind of like how they do. They're showing that this is a set. We're going to show that the domain is going to be this set of numbers and nothing else. All right, so I took the X value from each coordinate. Let me make that look more like a little brace. And some teachers will say that it has to be in order from least to greatest. Personally, whenever you write it with those fancy braces, you're saying that it's those numbers and nothing else. So it doesn't matter if they're in order, but just always read the instructions on your test because maybe it auto grades and whatever. But domain is this list, nothing else. Any questions? Okay, now identify the range. The range is all the what in a function? All the Y's. So look at your Y values now. Another thing I forgot to mention, when we're identifying our domain and range, if there are repeats, you only write it once though in your list. Got -2, -5, I already wrote down. -2 is already in my list. Then I also have -3. So my range is just these 3 numbers and nothing else. Don't write it multiple times in your list. Questions on number 1? You think we could try 2, 3, and 4 ourselves? They'll be able to tell me whether or not it's a function and what their domain is going to be. So Gianni, is number 2 a function? And what part makes it not a function? So we have in the x's a 2 that repeats. So I know it's an x because it's first in each parentheses. And then it has 2 different y values. I've been asked before, like, oh, but one's a -4 and one's a 4, like, aren't those the same? No. Okay, so it's the same x, 2 different y's. That alone makes it not a function. My domain for it, Kyle, would be what? What's my domain of this? Tell me the definition of domain. Domain is what? All the x's. So what are all my x's in this? Well, so if ordered pairs go x and then y, just tell me the x's. Like, I don't see a 4 in the x spot. So just from left to right, tell me all the x's. Okay, I'm gonna ask, are we missing any numbers? Anything else? Okay. Do I list it multiple times if it repeats? Does order matter? It doesn't matter. Some teachers might say they need it from least to greatest. It doesn't matter. Because when I use these little fancy braces, I'm saying this is all that's in my set. So my domain is these 4 numbers, right? Are there any other numbers for the x's that we missed? Asking all of you. So then this is it. I close it. You're done. Yes. Yeah. Like if in my number 1, because this one we established was a function, if I wrote 5, -2 again, I mean, yeah, the 5 repeats, but it's the same exact output. So like that would still be a function. I don't often see them try to trick you like that, but like just think about it. Can one candy bar have 2 different prices at the store? No, it's just one. So if it has like maybe 2 different prices, that's not a function. It doesn't make sense. So imagine that these all have like equations to them. I can't plug in the same number into the equation and get 2 different outputs. So that's how you should do that. So good questions. Natalia, what's my range? 3, 4, 5, 4. All right, class, sound good? Are those all the Y's? Okay, so then that's my range. Number 3, Lakeland, is number 3 a function? Yes, probably not. Okay, so we don't have to guess, guys. I explained it to you. We have the definitions up here. So it says, given ordered pairs, if the x values repeat, then it's not a function. Lakeland, can you tell me all the x values in this? Okay, So I'm also writing it down as my domain. I mean, I might make some changes to this, what we just talked about. But I'm also writing it down as my domain because I know that domain is all the x's. Now, are we supposed to write them if they repeat? No. Do I have any that repeat? The -3. So one, I'm not going to want to include it twice in my list. And two, if the -3 repeats, I need to look at that coordinate. So here's where the x is -3. Here's the other ones where the x is -3. Do they have the same y value? So that is a situation where, like I told you, it's like picking up a candy bar at the store and it having two different prices. That's not a function if that happens. So now my range, we need to identify. Gunnar, what's going to be my range? Okay, good. And we don't list the one that repeats. There is a y that repeats. That's not what we consider for like if it's a function or not. We don't care if the y repeat at all. But we just don't want to put duplicates in our list. All right, James, is number 4 a function? All right, so if it's a function, that means that none of the x's repeat. So let's look at the x's. Class, do we see any x's repeating in number 4? So yes, it is plus. And I just highlighted all the x's, so hopefully that makes it easier to identify our domain, which is all the x's. Is 1, 2, 3, 4, 5. Now my range, Angelo, for this one is what? Okay, good. Any questions? All right, Logan B, please go. So we just answered these. We know that ordered pairs can be shown in a lot of different ways. So that's like what the rest of the page is talking about. Not much has changed. So like 5, 6, and 7, these are all tables. To me, tables are even easier because they tell you which is X and which is Y usually. If it's a real world situation and they're not telling you which is X and which is Y, just know that X is usually what's independent and Y is what's dependent. So like X is usually time, which you can't change time, and things like that. But these are just lists of ordered pairs. Logan D is number 5 of function. You say yes? Okay, so do I see any x's that repeat? So then you want to change your answer? We have a 3 that repeats in the x with 2 different y values. That makes number 5 not a function. We're not going to list the domain and range of every single one because I hope it's easy now. But the whether or not it's a function is really key. So we are going to at least do the call. Hayden, would number 6 be a function? Did you say no? Which one repeats? So do I care if the y's repeat, class? No. I only care if the x's repeat. So I look at my x's, do I see any x's that repeat? So in that case, I don't even need to look at the y's. As long as the x's do not repeat, then it's a function. Because like at the store, can different items be the same price? So yeah, there could be 2 different things that are the same price, right? So that's why that's allowed, but you can't have one thing be 2 different prices.
Water.
I don't think that applies. When you scan at the store, is one price that pops up. All right, so 6 of the functions. Jenny, for number 7, is this one a function? Okay, good. None of the x's repeat, right? So function on function. All right, number 8, Rodolfo, is number 8 a function? Which one makes it not a function? Good. So I have the same x, 2 different outputs. That's what makes it not a function. All right, now 9 and 10 are examples of maps. I mean, you might have to create one on your practice. At the very least, you just need to know how to read them. So they always go from x to y. So like it comes out of the x to the y. Y is always dependent on what x is. So that's how you read it. For the maps, they always put them in order from least to greatest. So that's why like the arrows aren't just straight across, because they make them from least to greatest. So that's why they cross. And they don't list any duplicates. So if there are duplicates, you only see that with the arrows, like the multiple arrows either pointing to a number or coming out of the number. So for number 9, if I was wanting you to identify the coordinates, it'd be like, these are my coordinates. Okay, so that's just how you read it. These are the coordinates I'm giving them. Wyatt, is number 9 a function? Yes. I have, from my map, I can see each x points to only one y. Like there's not multiple arrows pointing out of any of the x's, so it is a function. And when I list them out like this, you can definitely see there's no repeating x's. Kathleen, is number 10 a function? No, which one makes it not a function? The -1 on the x side repeats. So yeah. I have the same input with 2 different outputs. So that is not a function for that reason. So when you recreate it, just kind of follow the lead of these two. The big piece is identifying whether or not it's a function. Now we're going to do from graphs. So on the back, we have 11, 12, and 13 are all what we would call discrete graphs because they have like just individual dots. When I list my domain and range for them, maybe I'll just do it for 12 because 12 has like 4 coordinates. When I list my domain and range for them, it's going to be similar to like what we did with 1 through 4, where you're just listing the x's that it is. And hopefully you guys know how to read your coordinate plane. If not, here's a brief demonstration. The x-axis is the one that goes from left to right. Okay, it's a number line. To the right of the number line, the numbers get bigger. To the left, they get smaller. So at the origin where the 2 axes cross is 0. So my first x of my domain is -3, then -2, they're not 1, and 5. It doesn't matter. My range, which would be the y values. Now the y-axis is another number line, but it goes up and down. So like take x to the left, y to the sky. When I go up on my y-axis is where the numbers get bigger. When I go down is where they get smaller. And of course, where they cross the x-axis is 0. Yes, question. So here, we'll talk about that in just a second. But first, if I'm listing my domain and range for 12, my range would be -3. And there's 2 -3y values, but -3, 1, and 2. That's my domain and range for 12. Question? So what I'm trying to say is that if it's dots, it's gonna look like what we did in 1 to 4. As far as testing where they are functions or not, you could like list out all the coordinates if you want. Or you could follow what it said on the front, which is that if you have a graph, you can use the vertical line test. If it intersects a graph more than once, it's not a function. So if I were to draw vertical lines through my graph, and usually they look like this, again, loading up. Yeah. Normally we'll do them like this, from like graphs that look like this. But if there are a bunch of dots, you kind of have to be going through where all the data is. If a vertical line is touching the graph at more than one spot, then it's not a function. So is 11 a function? No. It is not a function. It fails the vertical line test here. It only needs to fail once for it to not be a function. Because that's the same x with 2 different y's. Make sense? So that's almost like, instead of listing out all the coordinates and really looking at them, it's like an easier way to have a graph. So then, Gianni, would 12 be a function? Yes, it would pass the vertical line test. If I draw my vertical line, there's nowhere that it touches more than once. 12 is a function, and I'll have a lot of room, so I'm going to put it right here. Kyle, is 13 a function? Don't listen to him. Look at it yourself. He could be wrong. No, it actually fails the vertical line test. So at what x value does it fail at? So right here. See how if I draw a vertical line through there, it touches the graph more than once? That's where it fails. That makes it not a function. That makes sense? Can we emulate that? Okay. All right, moving on. These continuous graphs is more so what we use the vertical line test on. Logan, S is 14 a function.
No, I'm not sure.
Does it pass the vertical line test? Is there anywhere that it touches the same vertical line more than once?
Sarcastic.
Not a function? Okay, I agree. It's not a function. It fails multiple times, but on the ones I drew, it fails here and here, there and there. It only needs to fail once to not be a function. Yes? This? So if I drew my vertical lines, does it touch a vertical line more than once? So that would not be. Yeah. Natalia, is 15 a function? Good. Because it would pass the vertical line test. So there's nowhere that it would fail. And it doesn't more than once. Lakeland, is 16 function? Okay. Where does it fail? Remember, it's a vertical line test. You want to draw vertical lines. So look at what I have up here. These are my vertical lines through this graph. Is there anywhere that it touches more than once on the same vertical line? So is this one a function?
I was thinking of the.
Yeah, I wanted. All right, vertical line test, because we were trying to see if any x's repeat like these ones. All right, makes sense? Any questions? Okay, One more thing to add, so domain and range, super important. I mean, we've identified it a few times already. From continuous graphs, I could teach you the inequalities, but I just know like it'll probably be confused more. It shouldn't, but I know it will. Well, I need you to be able to tell me still, like if this is the one I'm asking you like domain and range about. You know, domain is all the x's. The x-axis goes infinitely left and right. Does this graph look like it goes infinitely left? So it has the little arrows, right?
Yeah.
Would it go infinitely to the left? Does it go infinitely to the right though? Where does it look like it stops at? What x value? So at least be able to tell me that my domain is, for example, 2 and below. At least be able to tell me that. So domain is all the x's, right? Yes. X-axis goes from left to right. Ask yourself, does it go infinitely left? Does it go infinitely right? No, like these arrows are pointing like diagonal that way and this way. So it does go infinitely left, but not infinitely right. It stops right here on the x-axis. And highest x value, which is 2. So at least be able to tell me if the x's on this line are 2 and below. Like it's not just going to be a list of numbers, because it really is every decimal from here to infinity. Negative. Make sense? Okay. Now the range is all the what? So the y-axis goes up and down. Does this graph look like it goes infinitely up? Will it go infinitely down? Yes, it's going at a diagonal, but as I go more to the left, it's going more down. What do we call it if there's no restriction at all? I suppose you could say negative infinity or positive infinity, but also all real numbers. So if there's no restriction either direction, we say all real numbers. Okay, I'm glad you asked. So all real numbers would be like negative numbers, positive numbers, every whole number and decimal in between. Yep.
So like, yeah, fraction.
Fraction, yes, the real number. I don't know what you're referring to. I teach 9th grade, not higher.
Oh.
All right. Oh, okay. There are like some other things, but all real numbers is what that means. So I'm also glad you asked about that because on your final, you do reasonable domain and range. So that means in relation to like the real world problem. So let me show you that one. So I'm going to give you the practice. It's on paper, the one that matches the notes we just took. And then in June 16th, you'll see all these practices. The other one I want you to start right now is the one that says reasonable domain and range. And it's only 3 questions. Because you just have to be able to, kind of like you were talking about, you don't know what that means when you see it on tests. You need to practice these like test style questions because you saw it on your final and yeah, you just need to be able to understand it. So a child tosses a baseball up into the air. On its way down, it gets caught in a tree for several seconds before falling back to the ground. Select the best description of the range. So range is all the what? What's my lowest y value on this graph? Okay, good, because like here would be like my lowest y value. What's my highest y value? So here about 12.5. Now look at what the y is labeled as. It's height in feet. Can I have a decimal of a foot? Yeah, like 12.5 feet, like you said. So if it can be every decimal in between, that's where you'll probably want to use the phrase real numbers. Because that includes decimals, whole numbers, positive, negative, like it includes them all. Yeah. If they're asking for a reasonable number. Now, it goes from 0 to 12.5, so that automatically excludes the negatives. If you read the answer options, it says like from here to here. So be able to tell me like my lowest, my highest, and is it everything in between or just some of them? So like the word integers, what are integers allowed to be? And maybe decimals. So they're non-decimals. They can, however, be positive or negative. Granted, if they're saying from 0 to 12.5, then that automatically excludes the negatives, but you tell me, like, should it be real numbers or should it be integers? Can it be a decimal or can it not be? Don't tell me, but like, answer them. Yes?
What would be imaginary? So, those are good.
We don't do imaginary numbers in 9th grade, but you can do them in 11th grade. Don't worry, we'll get there.
That sounds good.
Yep, that's over the 3. Imaginary numbers.
So, I'm gonna move.
Hold on a second. Any questions right now? I'm gonna pass out the practice, which is on paper, but then you also have this 3-question practice, which is in school education question. Okay, so I'm gonna pass that out.